Hello. So I thought we could look at some partner problems. I believe this is called assignment 75, 76 in class. Um, yeah, let's see how it goes. Um, where did one go? It just happened. Time to quack like a duck. Okay. Number one, the radius of circular oil slick expands at a rate of 2 meters per minute. And it says the radius is expanding at that rate. And so I know this is a change in radius with respect to time. How fast is the area of the slick increasing when r equals 25? How fast is the area changing? That's this, change in area with respect to time. And that's what we want to know. So we're told this is circular. So I know that a equals pi r squared. And if I take the derivative of a with respect to time, I can get dA dt. And over here, I'm going to have to take the derivative with respect to time. And I'll get 2 pi r dr dt. Okay, well, let's plug in what we know. We know r is 25, and we know dr dt is 2. So dA dt equals 2 pi times 25 times 2, which is 4 times 25 or 100. And don't forget the pi, and don't forget the units. So we've got meters per minute. Okay. Next, if the radius is 0 at t equals 0, how fast is the area increasing after 3 minutes? How fast is the area increasing after 3 minutes? Well, we know that the radius is increasing at 2 meters per minute, and after 3 minutes, this is 3 minutes times 2 meters per minute. And so we end up with 6 meters is our radius. And we want to know how fast is the area increasing. Okay, so dA dt we said would be 2 pi r dr dt. We know what our r is, 6, and we know what our dr dt is, 2. So this becomes 2 pi times 6 times 2, or 24 pi meters squared per minute. And did I have meters squared? No, I mean meters squared because I'm talking about area. Okay. Problem number 2. Hey, and I don't know if you see them, but like this one says 2c and then there's 3c and 4c. That's to suggest that these are cone problems. And then problems 5, 6 say I. I think those are intersection problems. Oh, look, 7 and 8 are L's. They're ladder problems. So I tried to keep them thematically grouped for us. All right, 2. Tank of water, shape of an inverted cone. I think everyone should have one of those standing in the backyard. Is leaking water at a rate of, so the change in volume is 2 cubic feet per hour. And yes, the water is coming out, and so I would imagine maybe this should be negative. But I'm hold on to that idea for a few minutes because I don't know what the problem says. The base radius of the tank is 5 feet, and the height of the tank is 14 feet. Okay. At what rate is the depth of water in the tank changing when depth is 6? So we want to know about our change in depth. We want dD dt when the depth is 6. Okay. I notice that radius is going to be changing. Here it's smaller than it is here. So I think this is an opportunity for me to think about using similar triangles. This is 5 is to 14 as r is to d. So 5 is to 14 as r is to d. We're looking for dt, so I don't want to get rid of d. I want to get rid of r. And I'm going to multiply both sides by d so that I can say r equals 5d over 14. This is what I'm going to plug into our volume of the cone formula. V equals 1/3 pi, not r squared, but 5 over 14 d squared. And then don't forget that d at the end, right? Because it's 1/3 pi r squared times the height. So we're going to have v equals 25 pi d to the third over 14 squared. Is that 196 times 3? Yeah, I know what 196 times 3 is, so happy calculator, come save me. 14 times 14 times 2. And I'm looking at 588. Okay, so there's my volume formula in terms of one variable. To take the derivative with respect to time on both sides, I'm going to bring down that 3. 75 pi over 588 d squared. Don't forget to come back and take the derivative of that inside d with respect to time. Now, this is the thing we're looking for, so I must know d, and I must know d dt. d dt is 2. But what about d? Do we know d? Oh yeah, they said when d was 6. So 6 squared or 56. So I'm going to multiply both sides by this, and I'm going to divide both sides by that. And as I recall, I think there's an answer at the bottom of this. So I'm looking forward to seeing if my answer is that answer, because these look like funky numbers. Okay, let's take a look. I'm supposed to take 36 times 75 pi divided by 588. I'm supposed to take 2 and divide by that number. That seems very improbable. And I get a number that does not look like the number down there. Oh, yes, it is. Oh, I didn't see the decimal point at first. Okay, so what I found for dt is 0.1386, and that's why the answer at the bottom says 0.139. And don't forget our units. This is a change in depth. Our depth is measured in feet, and so we want feet per, what was our time? Hour. Per hour. That's how the depth is changing. And remember, this is negative, so this is negative, so this is negative, and that means the depth is decreasing as the liquid runs out of this tank. Okay, part B. At what rate is the radius of the top of the tank, is the top of the water in the tank changing when the depth of the water is 6? Well, that's interesting. We need a dr dt, and I don't have a dr dt here. But you know what I do have? I do have some things that are handy. First of all, we're looking for when d equals 6. And then didn't we have that relationship where we said 5 is to r as 14 is to d? This could be important for us. So volume equals 1/3 pi r squared d. And now I'm going to do something rather bold. I'm going to, now I've got two approaches I can do here. Because I now know d dt, and I'm looking for dr dt, I could just do the product rule here and get dv dt equals pi over 3 2r dr dt times d plus pi r squared times dd dt. All right, and we know this is 6. We're looking for that. We found that in the last problem. We don't know radius. But we have this. Right. We can find radius by plugging in the 6 over here. So I'm going to have 5 over r equals 14 over 6, which is 30 over 14 equals r, or 15 over 7. And so now I can plug that in for these r's and get my dv dt that way. We know that d is this, and we're just going to plug in our answer to the last problem, that 0.1386 number can go in here. So that's one way where you just say, I'm going to do it in terms of both variables. But you could also say, all right, so I want dr dt, which means I want volume all in terms of r stuff, not d stuff. So when I look at v equals 1/3 pi r squared d for depth, I say to myself, okay, so if I want to get this all in terms of radius, what's d equal to? And I get that d is equal to 14 over 5r. So then 1 pi over 3 squared is 14 over 5r. Or 14 pi over 15 r to the third. Okay? Okay. So no, that's just me doing some algebra. Now I take the derivative with respect to time. And I get dv dt equals, bring down the 3, that 3 can cancel with a 3 in there, 14 pi over 5 r squared. Don't forget dr dt. Now, that's what I'm looking for. This is that -2 that they gave me at the beginning. But what about r? Well, they say when depth is 6. So if I plug a 6 in there for depth, I can solve that equation for r. I could certainly plug the 6 in here and solve that equation for r. So I'm going to get 30 over 14 equals r, as we saw in the last problem, 15 over 7. So I'm going to take this 15 over 7 and plug it in there. Don't forget to square that 15 over 7. And we know this is -2. And you want to divide both sides by all of this so you can get dr dt by itself. So I'm going to have -2 equals 14 pi over 5. My radius is 15 over 7 squared, and we're looking for dr dt. There's a little canceling here. -2 equals, one of these 7s will cancel with a 7 there, so I'll have a 2 and a pi. And one of those 5s is going to cancel as well. This is 15 times 15, which is 3 times 5 times 15. So if I get rid of one of those 5s, I'm going to have 3 times 15, or 75 left. So that's 75. And what do we have on the bottom? We took one of these 7s, we still have one. And we're looking for dr dt. So we're going to have to do a little work for that. If I multiply both sides by the reciprocal of this, I get -14 over 150 pi equals dr dt. You're certainly welcome to take a 2 out from each of those. I don't know that particularly helps. I will say that having the units could be useful. And to me, it looks like we've got feet per hour. Feet per hour. Okay? There's problem 2, cone problem. Problem 3 is also a cone problem. An inverted conical tank. Tip down. Has a height of 3 meters and a radius of 2 meters at the top. Water flows in at a rate of 2 meters cubed per minute. Okay, and so what's that? You know, if someone's named this calculously, what is it that we're naming calculously? That's right. This is volume. This is dV dt. Okay. At what? No, that was that one. How fast is the water level rising when height is 2? So they want the change in height with respect to time. And they tell me that height equals 2 meters. So we know V is 1/3 pi r squared h. I'm looking for dH dt. I don't have any dr dt, so I really need to rewrite this so it's just V as a function of h. Now, we're going to do that similar triangle thing again, where we say, okay, there's r, there's h, is to 2, and is that 3? Yes. So r is to h as 2 is to 3. We want to get rid of r, so solve this for r. R equals 2/3 h. And then we want to take this and substitute in it. So pi over 3, 2/3 h squared times h. So it's going to be 4 pi h to the third. Squaring 3 is 9 times 3 is 27. So here's V as a function of h. But I need dV dt. I'm looking for dH dt. So we now get to do the calculus part. Everything up to this point has been the algebra part. So dV dt equals 12 pi h squared over 27. Don't forget to come back and take the derivative of that inside with respect to time. Now, we know that dV dt is 2, and we know that height is 2. So 2 squared here is going to be 4. So to get dH dt by itself, I'm going to multiply both sides by the reciprocal here. 27 times 2 over 4 times 12 pi. And I can do some canceling. And 3, and I end up with 9 over 2 times 4 pi, or 8 pi. That pi is not next to, but under the fraction. Please make sure you have that pi under the fraction. Hey, look, 9 divided by 8 pi is what it says on the answer sheet. But of course, you know, this is a change in height, so let's not forget we're talking about meters per minute here. All right, that was problem number 3. How about problem number 4? 4 says gravel is dumped from a conveyor belt at a rate of, conveyor belt, dumping that over here. And we're creating this conical pile of gravel. Now I notice there's that 30 cubic feet per second. That's a lot. And so I know that's dV dt. All right. And what else do they give me? They say how fast is the height of the pile changing? dH dt equals how fast is the height changing when the height equals 10. But look, there's this other thing in here. It falls into a pile whose diameter is the same as the height. Diameter equals height. Well, I know diameter is the same as 2 times the radius. And since I'm looking for this, I got to get rid of r. So I'm going to say that r equals h over 2. So when I get that volume formula, 1/3 pi r squared h, I can replace that r with h over 2. Don't forget it's being squared times height. So we're going to end up with pi over 12, y 12 plus 2 squared is 4, and 4 times 3 is 12, h to the third. There's volume in terms of height. Now let's take the derivative of both sides with respect to time. So we'll have dv dt equals pi over 4h squared dh dt. Remember, we have to come back and take the derivative of that inside function. We did the derivative of the outside cubing function. That was bringing down the 3 and canceling with that 12. But we have to then go back and take the derivative of this with respect to time, which is why this says dh dt over here. Okay, so we know that h is 10 times squared. We're looking for dh dt, and pi over 4. We were told dv dt is 30. So that's going to be 120 over 100 pi. And we can simplify that as 6 over 5 pi. Cubic feet per second. Change in height then is feet per second. All right, there's problem 4. Ooh, intersection problems. Remember, as we head towards the intersection, rates are negative. Okay. Jade and Isaac are on motorboats located at the center of a lake. At t equals 0, Jade begins traveling south. So there's Jade. And at 32 miles an hour, moving away from the intersection. So I think dj dt is a positive 32. And then I see that Isaac travels east. Isaac travels east at the same time. There's Isaac, and di dt is 27, I believe. Yes. How far apart are they after 12 minutes? I don't know what that distance is. Okay. So remember, these are rates, and these are rates given in miles per hour. And it says, how far apart are they after 12 minutes? Well, 12 minutes times 1 hour over 60 minutes. I get some canceling, and I get 1/5 of an hour. So they're going to travel for 1/5 of an hour. This one is they're going 32 miles every hour for 1/5 of an hour. Remember, distance equals rate times time. So 32 times 1/5 will be this distance, 32 over 5. That's Jade's. And what about Isaac's distance? Well, Isaac was going 27 for that same 12 minutes. So Isaac is going to be 27 over 5. Okay, and what are we looking for? How far apart are they? Well, I can use the Pythagorean theorem here. 27 over 5 squared plus 32 over 5 squared equals d squared. So I pull out my calculator. 27 divided by 5, and I square that number. I get 29.16. And if I do 32 divided by 5 and square that number, I get 40.96 plus that 29.16. And so d is going to be the square root of 70.12. Which is 8.373768566 miles apart. Okay? And what about part B? How fast is the distance between them changing? Well, now we know what D is. D is this number. They're asking us to find d dt, the change in the distance with respect to time. So again, I'm going to go back to the Pythagorean theorem, and I'm going to take my derivative and then plug j and dj dt, and I and di dt, as well as d. Remember, this is d over here. I'm going to plug all those things in. So let's see what happens. Okay, so we've got j squared plus I squared equals d squared. 2j dj dt plus 2I di dt equals 2d dd dt. So j was 32 over 5, or was it 27 over 5? dj dt. That's 32 over 5 times, oh no, that was our j. Grr, hates erasing. These are the distances. But what about the rates? Oh, those are the miles per hour. Okay, so that's the distance. And their rate, how fast were they going? Jade was going 32 times 2 plus 2. Isaac was 27 over 5. di dt is 27 equals 2 times u. I'm going to write this 70.12 times dt dt. So I want to get that by itself, which means I'm going to do a bunch of multiplying, add those values, and then divide by this stuff. And yes, to make life easier, I'm going to get rid of all those 2's. So 32 squared over 5 plus 27 squared over 5 divided by square root of 70.12. Okay. I feel like I got a little mistake in there, but we'll see. 32 squared plus 27 squared. I want to divide all of that by 5. And then I want to divide that by the square root of 70.12. And I get 41.869. And these would be miles per hour. It's an interesting number. Let's see if it's the one on the bottom of the page there. I think this is 5. Yes, that's right. And no, that's not right. Drat. Well, let's go back and find out where Kukla's mistake was there. Can I just say, having lots of paper can be very handy. I'm feeling sad. Small board. Okay, so going back to the original setup here, we've got them going in opposite directions. There's the distance between them. J begins traveling south, 32, so dj dt is 32, and di dt is 27, and we want to know after 12 minutes. Okay, so my after 12 minutes was that d equals the square root of 70.12, and that was correct. But how did I get that? Well, I said that 12 minutes equals 1/5 of an hour, and I said the distance equals rate times time. There's my rate in miles per hour times my amount of time. So I've got 32 over 5. Actually, I want to write it as 32 times time, 1/5. But that's 32 over 5. And that's the distance that J travels. Okay. The distance that Isaac travels, to be Isaac, is going to be Isaac's rate times those 12 minutes. And so Isaac is going to be 27 over 5. Okay, so these are the distances. I'm trying to find dt. Okay, and so dt is something I'm going to get by using the Pythagorean theorem. I squared plus j squared equals d squared. 2I di dt plus 2j dj dt equals 2d dt. I'm going to take out all the 2's. My I distance was 27 over 5. dj, no, d, oh, this is I, sorry. Yeah, that's I. 27 over 5 is I, di dt is 27, j is 32 over 5, and dj dt is 32. D, we said, was the square root of 70.16. Square root of 70.16. Yes, that's our d value. And we have d dt. So I want this divided by that. I think that's what I have. 27 squared plus 32 squared over 5 over square root of 70.16 is going to be d dt. Okay, so 27 squared plus 32 squared, and I divide that by 5, and then I divide that by square root of Alexa off, 0.16. Alexa off. Okay, and I get the same number. Oh, that's very interesting. Maybe even disturbing. Definitely interesting. Yeah. Oh, there it is. So it turns out that the answer was, in fact, dt equals 41.869. And it's just that the answer that I've written here at the bottom of the page is not the correct answer. So let's change this answer to 41.869 miles per hour. Yes. Nice. Okay. Well, we got to do that one twice. Do you feel lucky? All right. So that was number 5. Number 6. A road is perpendicular to a highway. It leads to a farmhouse located 1 mile north. Farmhouse. 1 mile north of the intersection. The car is traveling on an east-west road, 60 miles per hour. dCdt equals 60 miles per hour. How fast is the distance between the car and the farmhouse changing when the car is 3 miles east of the intersection, heading east? Well, this is east over here, and so we're east of the intersection, heading east. There's our car, and we know dCdt is 60. And the distance between the farmhouse and the car, that's this distance. We're asked here in part A, how fast is the distance between these two changing? And when the car is 3 miles east, so C equals 3 miles. Okay. And we want dt. So this is a constant 1 mile, by the way. The farmhouse isn't getting closer or further away. So we've got 1 mile here. And if I use my Pythagorean theorem, I have 1 squared plus, changing quantity. You have to plug in that c equals d squared. So now when I take the derivative with respect to time, the derivative of the number is 0. The derivative here will be 2c dc dt. And the derivative here will be 2d dt. Okay, so what do we know? We know that dc dt is 60 miles an hour. 60. We know that c is 3. This 2 and this 2 will cancel. D. Well, I don't know D yet, but I can use the Pythagorean theorem to find D. I think that D is the square root of 10 miles. So, square root of 10, d dt. I'm trying to solve for d dt, so I'm going to divide both sides by square root of 10. So this will be 180 10 over 10, or 18 root 10, and my units will be miles per hour. All right. B. How fast is the distance between them changing when the car is 3 miles east of the intersection heading west? So now the car is headed this way. And what does that change in all of this? Well, instead of a positive 60 because we're moving away from the intersection, I'm going to have a negative 60 because I'm moving towards the intersection. Does anything else change? No, just that. Okay. We do not have time for another. I'll see you in the next part for problems 7 through 14. Okay, take care, everyone.